Hey guys, we're gonna make a little gearbox here, okay? I'm gonna demonstrate how this stuff works one more time, okay? So here we go. We got 4 different gears, different colors: 10 tooth, 20 tooth, 30 tooth back here, and 40 tooth. Got a couple axles, couple blocks, okay, that we can use to assemble our parts together. Notice if you wanted more of any part, you can insert those parts, and they're all here. Okay, but I don't think you'll need to for our examples, but feel free to experiment. So the basic rules are for this type of thing: use the block with the same number as the gear. Remember, the number on the gear is the distance in inches from the center to the root of the gear tooth, okay? And that distance matches the center of the block to the bottom and or top of the block. These blocks are symmetrical. So by using the blocks on the gears and then stacking the blocks, we can build our setup. So let's make a mesh of a 20 tooth and a 40 tooth. Okay, so what I'm going to do first, I'm going to take the 20 tooth 393 and the 40 tooth 783, and I'm going to join 2 of those. So I'm going to fasten the top of the 393 block to the bottom of a 783 block. Okay, and once again, the blocks are symmetrical, so the top and the bottom doesn't really matter which way you go. And I'm going to accept that. And now I have a set of blocks here that are linked. And I'm going to move that over, and that'll be our spot where we're building. Okay, I'm going to fix that in place, right-click, fix, so it can't move. Okay, next thing we need to do is we are going to put axles in these holes, and we're going to make those revolute so the axles can spin. Okay, now because we put the 2 blocks together, we know that the distance between these 2 axles is perfect for the 40 to mesh with the 20. Okay, how awesome. So I'm going to revolute. Let's pick a center of the axle, and let's pick the front of this cylinder. And that looks great. And I'm going to click the green arrow in the small box to start a new revolute mate. And let's pick the center of the axle, and let's pick the front of this doohickey right here. I want this cylinder. I want to make sure I'm on the cylinder here because there we go. Because you never know if you're going to get messed up. So there we go. We got our 2 revolutes. Pretty awesome. And now we're going to just attach the gears. Okay, so we're going to fasten the gears because the gears are a tight fit on these axles. These are actual gears and axles that we have in the classroom. And they're modeled, the dimensions are modeled perfectly. Now I'm going to accept that fasten. I'm going to create another. The gears may not look perfect here in OnShape because they're not, but the numbers are perfect and the pieces are perfect. So if you make something, we're going to fasten the front of this gear to the front of this axle. What you make in here can be used in the classroom. So there we have it, folks. We've got our perfect setup. Now, if you look closely here, these gears may not look like they're meshing right, and obviously they're not, but the roots of the teeth match, and you know, it just comes to the fact that I designed the gears kind of off with the teeth, but the numbers work well and are proven in class. So, all right, last thing to do is make them spin together. Okay, when we spin the big gear, the little one should go, and vice versa. So for that, we use the gear relation right here. And what you're going to do is you have to pick 2 mates that you want to relate, 2 revolute mates. So we're going to pick this one, the 40 tooth, first. And then we'll pick this one, the 20 tooth, second. And now you will see that the gears, when they spin together. Okay, and that looks pretty awesome. Now, I will have you know that it's not right. We're not done yet because you know that there's different teeth on each of these gears. They should not be spinning at the same speed. And if you look closely down here when I spin this, watch the 2 teeth, the 2 sets of teeth. They are sliding at a different rate. You see how they're grinding through each other? The blue one looks like it's slipping through. They should look like they're exactly touching at the same time. And the reason they're sliding and grinding is because we have set, in the gear relation, we have set a 1-to-1 ratio. See ratio? We need a 40-tooth to 20-tooth ratio. Okay? So that's 40 over 20. Okay? You could put 4 over 2, 4 divided by 2, 2, but you can just put the teeth in there and it's going to work out. Now, watch, when we spin one of the gears, they perfectly are synchronized. There's no sliding going on, okay? They're in perfect synchronization, all right? And what that gives you is a visual on, if you spin the big gear, the small gear looks like it's going faster. And we can animate this. You can see it a little better when you animate it. Let's have it go 360 degrees in 80 steps. We'll make it go faster. We'll have it loop. See, the little gear is spinning twice for every spin of the big gear. And that looks correct. Now, if you animate the second one, the small gear, we're going to do the same thing. We'll do 80 steps. That basically controls the speed, and we'll loop it. And it, it's basically the same. The big gear is spinning 1 revolution for every 2 of the bottom. All right, so that's how you build the challenges, folks. When you get to the triple combos, that's where you're going to have to think it through a little bit, okay? But I'm leaving you with that. It should be enough to get you going. Enjoy the process, and I'll see ya later.